Hello, I'm going to talk about Scaps, or how we can retrieve values by types. Maybe you notice that I slightly changed the title. It's just that this one is more catchy, I guess, a bit less technical. The content, I want to answer these 4 questions. First, what is Scaps? Why do we need it? How is it done? And what comes next? But let's start with who I am. I'm Lukas Wegmann. Currently, I'm working at the University of Applied Science in Rapperswil, Switzerland. We try to push Scala in some courses and also do some student projects on the topic. There's apparently a lot of interest from students in this area. So yeah. Besides Scala, I mainly work on statistical analysis and refactoring and modeling tools, mainly for C++. So let's start with Scaps. It has one purpose, that is find reusable functionality in libraries with types. What do I mean by reusable functionality? Well, it's everything in the public value namespace of a program, like values, methods, and constructors. I do explicitly exclude snippets, code snippets from the search scope, because yeah, when you can reuse it, maybe it should be a function. And types are also not directly indexed, but you can retrieve types with the functions that are defined on them. So it's not that you can use it to discover new types, but you have to know how you formulate the query. By libraries, I mean the project you're working on, all its dependencies, and it would also be nice if it's possible to search all of the Scala libraries for potentially new functionality that you haven't been aware of. I think this there's this trend in the Scala community to write very specific libraries for one purpose. And this would be nice to make them more discoverable. Yeah. And with types, well, what does it mean? You have, say, you need some functionality that transforms an A into a B. And of course, a function that does exactly this, like A to B, is the ideal match. But you also may be interested in an implementation that needs an additional argument that accepts a supertype of A, or it returns a subtype of B, would also be acceptable. Maybe it returns the B in some computational context, like an option of B. It takes the A in some context. Maybe there's some currying involved. So the A is, you have to first get a function that gives you the B. Or you pass the B to a callback of the function. So a typical example is a function that also makes some resource management. So you have a file name, and the function gives you the file and closes it, the file handle, after you have used it. Or put to the extreme, you can have functions like this, where the B occurs in the argument position. So you pass to it a promise that eventually will accept a B, and it returns a promise that will that you eventually have to write an A to it. So there's a lot of variety. Yeah, and sometimes types are not enough. So especially side effects, you want to describe with some keywords. So what should it do? So I add the possibility to use keywords to specify what functions you want to find. So that's how it looks. Maybe you all already tried it. Who has been on ScalaSearch.org before? Yeah, still a few. That's cool. But I'm going to show it to you. So that's a website. Okay, yeah, you basically can formulate your query, select the libraries you want to search on, and hit enter. Yeah?
Your website says that you can search for symbolic operators, right?
Yeah.
And can you search for operators that are predefined, for instance, plus on integers and stuff like that? So plus on integers, it's not written anywhere in the code, so it's just there magically introduced by the compiler. So can you find this kind of stuff?
I guess it is defined in the Scala standard library.
I think it is actually. It's not compiled, but it's not.
So we can try.
Yeah, let's try plus. Oh, multiply.
So it gives you, yeah. Okay, that's a bad example. Does someone have another question to the search engine? Like, do you need a special function from the standard library? I did. Two set.
Converting to a set. I don't know.
So, what do you want to convert?
Well, what can I convert?
Say a list.
Yep.
Oh, so yeah, there's a couple of sets. So we have to specify that we caring about mutability.
Why can't you just search for all of them?
That's currently not possible, but I'll come back to this point later. Yeah, it also retrieves apply, but I guess this is a pretty good match. Or are you satisfied? Cool. So why did I thought this is a topic to spend time on it? So actually I did this as a master's thesis. So it started as this master project. The problem is that I always had the feeling that there should be something between the code completion we all know and probably use very often, and the point when you go to Google and ask some specific question and mostly find the answer on Stack Overflow. My favorite example is makeString on a list, because I always forgot that it's called like that. So I was used to join or something like this. What do I mean by expressiveness of Scala? Java util list with this imperative style of coding defines 32 methods to modify the list and make queries on it. And Scala collection list has 177 methods defined. So you have to, yeah, you need something more than code recommender to find what methods from this do you need. Also, there are more. Maybe there's a library that defines more list functions, and you don't know about them. This problem also starts to become bigger in Java with the immutable streams. So there's an additional 45 methods that can be used on list. So yeah, you need some tool for that. My second claim is that we are actually pretty good in formulating problems as types. So when you look at these Stack Overflow questions, you can easily translate them to a query to Scaps. What's that? Also, Google knows this. So when you search for something without my personal filter bubble, so this is in private mode, you also will get some recommendations that are basically a type list to map or to string or whatever. My third claim is that Haskell is that we have so I have to sort of over. Haskell has this wonderful tool called Hoogle that does exactly what I described earlier. It allows you to search values with types. But the approach that Hoogle takes is based on graph traversal. So there are this graph of types, and it traverses it to retrieve good answers. So there's more to it. It's also very complex and optimized. But I guess this is the basic idea. The problem we have in Scala is that there are those huge inheritance hierarchies, like the collections. The most generic collection type has more than 350 subtypes. List has 50 subtypes. And when you combine that, and so you're interested in a specific subtype of, say, this function. So list to generic traversable ones of generic traversable ones was actually a quite useful query in some occasions. You get more than 6 million subtypes because of the combinatorial explosion that comes with the principles behind it. So we need a new approach. So how? Well, the first part about the keywords is pretty easy. We have already a good tool that takes care of it. I use Lucene. It takes care of the stemming of the words, and so sort will match sorting or sorted or whatever. And yeah, what do we do about types? So the basic ideas is that we use a technique that is familiar with all the search engines. So we have some terms that describe the documents, and we use the terms to quickly retrieve documents that are described by it. This is an inverted index. But types are more than just a list of tokens. So we have to transform them to make use of this idea. What do? First, I normalize the types to get rid of the parts we don't care about. this is mainly arguments, so like everything gets carried, constructors or just functions, and method invocations are also just functions. Then I add the polarity of each part of the type. What does this mean? Well, there's all these highlighted types in those queries have something in common, namely that the caller of the function eventually reads the according value. So we call this covariant. The same is the same applies to these types. They are eventually written. So the user will write it to the function or pass it to the function. The pictures don't match. Sorry. Yeah, and we have also some types that use invariants. So an array you can write to and read from. The same goes to the Java lists or Java collections. So those are invariant. So we can use this polarity to better describe what each type in a signature represents. Yeah, and so we add it in the second step. Then there's probably the biggest problem about those generic methods, namely type parameters. So the problem here is you type parameters have some relationship, like the A should match this A in a concrete implementation. So when A is an int, here should also be an int. So when you reorder the type parameters, you probably will have a different function. Also, users can name their type parameters however they want. So maybe key and value is a good name. I thought a lot about it, and the solution that finally worked best was to just ignore it. So I replace every type parameter by their most generic bound. So like type parameters at contrariant positions are replaced by upper bounds. Yeah.
What happens if you have two?
So the question is, what happens if you have two type parameters and somebody actually wants to do a query on having both? I mean, an example might be a tuple of A comma B going to B. Does that mean doing this drops all the information?
Yeah, it basically drops it. But when you think about it, it's not that often that you just drop some information. So, and even if you do, there's only two possible ways to drop it. So we lose some precision, but we gain a lot simplicity. So, yeah.
So you cannot find like something that goes from a tuple of AB to a tuple of BA, which would just swap the order of the argument?
Well, you can find it, but you have to see it in the result set. But this specific query, like for a swap function, will probably retrieve the right result, because there, you have the identity from tuple to tuple, but there's not much more that that is possible. So it's not.
My question: we can process after the result set after this simplification and gain only these things which we are interested in.
Yeah.
This will be solution, simple solution.
Exactly. So you always can process it however you want. So maybe you have to do some additional type checks, but yeah, it's.
Is that what you do, or?
No, I don't.
Okay.
But because currently the interface is directed to users on the website, and usually they are smart enough to figure it out how it matches. So it's a compromise. So you want to have always the exact result, but it works really good, and yeah. I hope you will agree with me, or yeah. And finally, we now have this this annotated type with the polarities, and we just flatten it so we get a string of terms. And those terms are then finally fed to the index to retrieve the values. So we can use the inverted index to quickly discover what functionality we want. What have we lost? So we already talked about it. So here's some more information. When we take Scala list as an example, we have 177 members. Those have there are 118 unique type signatures. So some share the same, and those type signatures will be transformed to 107 distinct fingerprints. So there are some collisions. So some type signatures that are transformed to more some fingerprints that are derived from more than one type signature. Basically, this is fold left and fold right. It's related to the problems you mentioned. But when you think about it, actually they are isomorphic. So the order of the parameters of the callback you pass to it doesn't really matter for the implementation. It's just for the user to know what comes first, or how is the data folded. Another collision is equals and contains. Here is the problem, the legacy from the Java object type. So equals is, in this case, list of A to any, and yeah, that's not easy to, and contains is list of A to list of A. So here's also, yeah, some information we lose through the replacement of the type parameter. Yeah, let's query this data. First step is to parse and analyze the query. We do some name resolution, do the same transformation, and get the annotated type. And then we expand this type to a query expression. This looks like this. So it's basically like a mathematical expression. You have some sum nodes and some max nodes, and the terms from the original query. During this expansion to the query expression tree, we map all alternative terms that could be relevant to the query to the expression tree. So when you ask for something that accepts a string, you might also be interested in something that accepts an any. So yeah, this is contravariant. The other way around is with return values, where you look for a set of int, but you might also be interested in a function that returns a bit set or a nothing. And finally, we score each of these terms with some value. That is the relevancy of the term to the query. Now we can use this expression tree to fetch data from the index that then gets evaluated against this expression tree. So here I just select the best scored terms and will fetch fingerprints from the index. For example, I have received a string any set and invariant string term, and now can evaluate, assign each of these terms to the expression tree to finally get a score. This is not a trivial operation, but it can be done pretty fast. You also can rewrite those expression trees to reduce the overall size of it. So this is a pretty good optimization of the general approach. Yeah, this is a general overview.
On rewriting of the queries, would you ever consider removing things like the nothing in the query? Or do people actually care about that in the query? It might simplify the query somewhat.
Yeah, the question was if we whether we consider to drop some arbitrary information like the nothing from the query during rewriting. Actually, it's not necessary, and you would lose some structural information because the nothing represents the parameters, the type parameters that are maybe present in the fingerprint. So we keep it. Yeah, the nice thing about this approach is that it goes well with subtyping and implicit conversions. So we basically just say implicit conversions are the same as subtyping, what is actually is. It handles all kind of isomorphisms. It also works with higher kind of parameters. So I really like this slide, so especially this query, because it can handle, well, future.sequence, which has a pretty ugly type signature. But yeah, you can try it. It's the first result. And it integrates very well with text retrieval. So you can just add the scores from the text retrieval with the scores from the type retrieval. As I already mentioned, the evaluation is not that easy. It's also quite expensive. And we have to collect some statistics about the types in a library. So this collection is only possible when you have so you need all types and all subtype relations, the type views, to collect these statistics. That's also expensive, and it makes some things more complicated. You have also to choose in what direction you want to search. So are you more cared about the structure of the type or about the type hierarchy? So you have to balance those two dimensions. That requires some configuration, and you usually don't want to the users to care about this. So you have to come up with some good parameters. And type classes are not yet supported. So currently this query, list of ints to an integer, does not match, or it matches but not really good. List of, so the list.sum method, because there's implicit parameter that is required. And this is a good transition to the what's next, because this is what I'm currently working on. And the idea is to create synthetic values in the index that actually instantiate, so I call it instantiation, all values that use an implicit parameter that is a type class, and with all available type classes. This blows the index a bit up, but it's not that big a problem. Actually, this is more flexible than just type classes, so we can also handle things like the subtype witness from option.fold. Yeah, those additional values from the type class instantiation require also that we become faster with the query time. So currently I have indexed the Scala standard library, Scala set, and Scala refactoring in a test collection with 150,000 documents, and the query time is about 500 milliseconds. That's not too good. So yeah, there should be some work directed to performance, because as I already mentioned, we want all Scala libraries. So and a good response time is probably less than 100 milliseconds. Another topic, I think this is also very important, because the web interface is not really intuitively to use. It would be much more easy for the users to invoke the queries directly from the IDE. This would look like this. So you have some expression that does not type check. Yeah, let's query it. So it should be possible to extract the types of the parameters used and the expected return type, or you may have to annotate it, but yeah, this would be pretty interesting. But the integration into the development environment requires some incremental indexing, or it would be really good if we had this. So there's also some more effort needed in this direction. Yeah, I skip over this. Yeah, and there are some more features that would be nice, but yeah, need some work. Type alias, for example, shouldn't be too hard, but yeah, it's not yet done. Can we port this approach to other languages? I guess this, especially when we had this for Java or bytecode, it would be a really nice addition, because it allows you then to query all of your dependencies and not just the Scala one. One difference in Java is that it doesn't use the definition side variance annotations that we know from Scala. So it may be a bit more complicated to get the required information. C# would be so this one would be a really nice target for this approach, because the type system is quite close to Scala's, and maybe it would also be possible to port it to Haskell and have similar or better performance than Google. I don't know. Yeah. So, thank you very much.
So, in the results page, you've got a button that says this is what I'm looking for. Are you doing anything with the data, or are you just collecting it at the moment?
At the moment, I'm just collecting it. I didn't got that much feedback yet, so but I have it, so maybe I can do something with it. So I regularly check it. What was the query? What was the output? But actually, the problem is it's more interesting which query couldn't be answered by the search engine. So it's harder to get to this data.
Okay, are there questions? More questions? No. So let's try to switch to Dave lightning talk right now.